this problem, we're going to be figuring out a bunch of different things based off the given graph here. We're going to find the domain and range, intercepts, where it's increasing, decreasing, constant, and if it's an even, odd, or neither function. So first off, let's start with the domain and range. So when we talk about domain, we're talking about the span of all the x values. So x values, axis is our horizontal axis. So when we look at domain, we're essentially saying from where to where does our graph live? What's the leftmost area our graph has, or the rightmost area? All right, so our graph fits within what parameters? And if we take a look at this graph, and again, when you take a look at graphs visually in math, you should always look at them from left to right, bottom to top. So domain is your left and right. So looking at the left area, our graph begins at this point right over here. And when we state domain and range, we state domain and range in interval notation, which is based off of your x-axis, from where to where. This particular graph starts at this point right over here, which looks like the point 0, 1. We're going to focus on x, so it starts here at 0. And then this graph goes, and it ends right over here at this point, which looks like a 12. So therefore, our domain is from 0 to 12. That is where our graph lives. There is no graph over here in the negative space. There is no graph further past 12. That is it. From 0 to 12, that's our parameters when we're looking horizontally. So 0 to 12 in proper interval notation with our brackets, since we do have solid points at either end here. Our range is just bottom to top, our vertical, from where to where is your graph. So if we take a look at this example, there is no graph down here. Our lowest points are these 2 points right over here. And for the range, we're looking at the span of our y values, right? Domain, x, left to right, range, up and down. So our y values, the bottom and the top part of it. So our graph, the lowest point is a 1. If we look at the peak of our graph over here, that looks to be about a 6. So we can safely say that our graph stems from 1 until 6. There is no points higher than 6. There's no points lower than that 1. So it looks like our range goes from 1 to 6 across our y-axis. Now when it comes to the intercepts, they're referring to your x-intercept and your y-intercept. So if we look at our x-intercept, that is where your graph crosses the x-axis. So our graph hits the x-axis at this point right here. And that's the only point that it looks like that it crosses through this x-axis. So that intercept is whatever that point is on your x-axis. So that looks like the point 0, 1 for our x-intercept. For our y-intercept. All right, that is our y-axis. It hits the y-axis. I'm sorry, I said x-intercept. For our x-intercepts, though, which would be the next thing that we look at, it's where on the x-axis does our graph cross. Now, if we take a look at our graph here, it's never going to intersect this x-axis here. It stops right above it. So there is no x-intercepts whatsoever for this example. Had it crossed past this x-axis, then we would have one. For our example, it just doesn't exist. For the next thing, we're going to look at where is it increasing, where is it decreasing, where is it constant. For increasing, decreasing, constant, we write our answer in interval notation using only parentheses. Increasing, decreasing, constant is always open-ended, so you always use parentheses for that notation. You will never use brackets for increasing, decreasing, constant notation. So increasing is where does your graph have a positive slope? Looking left to right, where is it rising? Where is it climbing up, going in that upward direction? So if we take a look at this particular graph, our graph again starts at this point here. And if we take a look from this point, we're shooting up, 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 going in an upward motion. That is what increasing looks like. When we reach the top of this peak, it looks like we turn around and we start going down, 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 until we get to this point right over here. So for our particular example, we only have an increasing section and a decreasing section. Constant would look like a straight horizontal line. You're going straight across. You're not climbing. You're not going down. You're staying straight and steady. We don't have that in this situation here. It looks like we only have increasing and decreasing. So we are climbing from this point to this point here. So you need to look at your x-axis, your x values for that. We are rising from 0 to, it looks like, a 5 here in the middle, right? Do keep in mind that these go by 2s. So this point here looks to be about a 5. So we can say from 0 to 5, right, is where our graph is increasing, where it's positive, where it's climbing. At this 5, from 5 until the end of the graph here is where it is decreasing. So we can say from 5 to 12, this is where we're turning downward and going in the negative direction. So 5 to 12 would be, I'm sorry, I wrote that under constant, would be our decreasing section here. Then there's the question, is this an even function, is this an odd function, or is this neither? Quick answer, this is a neither case. An even function has y-axis symmetry. So it's even only if you can fold your graph across the y-axis. Picture this little graph that I have over here. This is an absolute value graph. If we were to fold this graph on this line on the y-axis and fold it perfectly in half there, everything on the left matches up with everything on the right. That's what an even function looks like. If we did that with our graph, here's our y-axis, and if we folded this, there's nothing on this side, so it definitely does not match up with the right side. So it's not an even function. An odd function means that you can fold it across the y, and then you can fold it across the x. A visual of that would be like maybe something like this. If you can picture this top part being folded down, right, which would make it to this line here. And then if you can fold it the other way as well and fold this in on itself, right? So it's a flip down, then a flip across, right? Think about folding a paper in force. Fold it down, fold it across. If everything matches up when you do that, then it's an odd function. Again, we can't do that with our graph that we have up here. Again, if we just fold it on the y, it doesn't work. If we fold it down along the x, it's definitely not going to work. So this is definitely a neither case.